So in this video, we're going to get an intro to basic data structure. Data structures in Python are containers that store and organize data efficiently. In this video, we'll be discussing three types of data structures, namely lists, tuples, and dictionaries. First, we'll start with lists. A list in Python is a mutable ordered collection of items, allowing duplicates. Now, mutable means that it can be modified after creation. You can change something, add something, remove something, etc. Ordered means that they maintain the order of elements that you originally give it. You can access the elements, therefore, by lists, which start by the numbered list, which starts from 0 until the n-1th element. Heterogeneous means that lists can contain elements of different data types. You can have integers, strings, floats, or even other lists as elements within a list. And slicing is when you can extract sublists from a list using slice notation. So now let's look at some of the syntaxes that we have regarding lists. So first is creating a list. We start by giving a name for our list. Here we've given fruits and we say equal to, just as we do when we assign any variable as well. And then you use square brackets. Now within the square brackets is your list, and separated by each comma within single quotations is each element of your list. This is the 0, this is 1, and this is 4. Even though there are 5 elements, we number till 4. Now, we use this to access elements. For example, if I want to print the first fruit, I say print fruits with square brackets 0. Now, the 0 is the first element. The last one is -1. So, 4 can also be accessed as -1 as it's from the back. So, you use a negative sign with the position of the element. Adding and removing is something that we'll be discussing in the next video. To iterate over a list, we can use a for loop. Like here, we've done for fruit and fruits, print fruit. So it'll print each element one by one till the list is over. To check if something is in the list, we can use an if-else statement. Like here, we've done if banana is in fruits. Print yes, it is. So what this does is when you write this part here, it'll look for this word within your list, and it'll iterate through the entire list. And if it's there, it'll do this, else it'll say no. Now we can see that this list is not in alphabetical order, and say that we want it like that. We just use the syntax fruits.sort. Now fruits again is the name of your list. So this can be anything else. The syntax is .sort with brackets like this. Now display this list that we just sorted, you just say print fruits, because now the list has been changed to alphabetical. So you don't need to say print sorted fruits or something. You can just say fruits because it has not been changed. Some more advanced operations include copying a list. So to copy a list, you create, so here we have our original list, and we give a new variable, a new list name called copied list. And the syntax here is the name of the original list dot copy with bracket. And now when you print copied list, which is the new list name we just created, you get the same list again, but now you get 2 different name lists which have the same input. Now to create a nested list, we create a list here, but this time we are using square brackets within square brackets. So now we have lists. Here you can see we have 3 lists within another list called matrix. Now to access an element in this sort of nested list, what we do is we write the name of the list, and instead of previously, we only put 1 square bracket. Now we need to use 2 because we need to specify both the row and the column. So here, the first number is the row and the second number is the column. So that's how you get a particular element. So here we've done 1 and 0. So that means we want the second row and the first column, which here is the element at 2, 1. Now to slice a list, we have a list called numbers, and we want a subset from the second element to the 6th element, because the last one here that we mentioned does not get counted. So when you print subset, you get the second element till the 3, 4, 5, 6th element. Now let's look at tuples. Tuples are immutable ordered collections of elements used to store heterogeneous data. Immutable means that once the tuple is created, the elements cannot be changed or modified again. So this means the list that you create first is final. You cannot add or remove anything from it. Now, some features of tuples are that they are generally faster than lists, especially for accessing elements. and also that they consume less memory compared to lists, making them more suitable for small collections of data. Now let's look at the syntaxes. So creating a tuple is the same as creating a list. You just write the name of your tuple, but this time instead of using square brackets, notice how we've used normal brackets. So this differentiates a tuple from a list. Now to access, we do the same thing. You just go to my tuple or the name of your tuple and you write which index you want. Now concatenating tuple. Concatenating means adding two different tuples to get one final tuple. So here we have tuple 1 and tuple 2, and we're creating a new tuple called concatenated tuple, and the syntax is tuple 1 plus tuple 2. So now when you print the concatenated tuple, you'll get a tuple with 1, 2, 3, comma, A, B, C. So it'll just add these two and create one big tuple. Now to check if any element is in a tuple, it's the same as before. You use an if else statement. If hello is in my tuple, print yes, and else no. Moving on to dictionaries. Dictionaries in Python are mutable collections of key value pairs, allowing efficient retrieval and modification of data. So like lists, these can be modified once created. And keys and values are the two parts of dictionaries. So keys in a dictionary are unique and immutable objects used as identifiers for each value stored in the dictionary. Values, on the other hand, are the data elements associated with each key. Let's see what this means. So here we've created a dictionary. This is a key and this is a value. So they are separated by a colon. So to create a dictionary, we name it, and this time we use curly brackets, and in single quotations, we write the key and the value, comma, next element is its key and its value. So here the keys are immutable, but you can change the actual values, which is the actual data that you're collecting. And here we can also see an example of a dictionary within a dictionary. So grades, and this is another dictionary as the value of a key within this dictionary. Now to access values, you can just say print student name. Now this is the key. So it'll go here, and what it'll print is Alice. It won't print the key since the data here is actually Alice. So similarly with age, when you say print student square brackets age, it'll print the value associated with that key. Now to add a new element, we start by writing the name of the dictionary and the key name. So the key name within square brackets and single quotations, and equal to, in single quotations, we give the value. Now this will go into the dictionary as city, New York. It's similar for updating a value. You treat it as though you are adding a new key value pair, except because this key already exists in our dictionary, it'll just change this 20 to 21. To remove a key value pair, we use the syntax del, which is for delete, and student, name of the dictionary, square bracket, and the key. So notice how all the syntax is being done through the keys, not the values. The values are the data. We access everything through the keys. Next, to iterate over keys and values, we simply use a for loop like we did for lists and tuples. So for key in student.keys, we print key. Similarly here for value in student.values, print value. Now to check if a key exists, we use an if else statement. So if city in student, print city, student, and square brackets city. So here this is looking for the key again. If this key is in here, it'll print the value that is associated with this key. And since here we don't have this city key in our dictionary, it'll print city information not available. You can also create nested dictionaries, and their format looks something like this.